So this article is from Medical News Today, and it was written by Hannah Nichols, and it was published October 20th, 2017. She talks about how nerves fuel prostate cancer growth. So there are certain nerves that support the growth of prostate cancer via a tumor vessel proliferating switch, as found by a study of researchers from the Albert Einstein College of Medicine. And this finding potentially could lead to a new strategy for treating prostate cancer. The article gives some background on skin cancer and prostate cancer, but they start to talk about how norepinephrine can trigger a metabolic switch. They found that the nerves of the sympathetic nervous system, which control the fight or flight responses, will divide the growth of tumors by producing the neurotransmitter norepinephrine. It's going to promote tumor growth by binding to and stimulating the receptors on the surface of tumor connective tissue cells. So they had used a mouse model of prostate cancer, and they had found that through this that the connective tissues are fueling the tumor growth. Nerve fibers release norepinephrine. It's going to bind to the receptors on the endothelial cells that are lining the insides of the blood vessels. And this binding is what activates an angiometabolic switch, which alters the way cells metabolize glucose. Endothelial cells originally get their energy to produce new blood vessels from glucose using oxidative phosphorylation. However, we're instead using glycolysis to metabolize glucose. And this phenomenon was recognized in cancer cells. Oxidative phosphorylation prevents tumors. And so this group of researchers set out to confirm the role of norepinephrine in triggering the metabolic switch. So what they did was they deleted a gene in a mouse model that looks for the norepinephrine receptors on the cell surface, and then eliminated its binding target. As they had predicted, the cells that lack the receptors, they used oxidative phosphorylation to metabolize glucose rather than glycolysis. And this is what would inhibit the formation of new vessels for these cancerous tumors. So this quote from Dr. Paul Frenette, it says, "Oxidative phosphorylation generates more energy than glycolysis. It may seem counterintuitive, but this energy boost provided by oxidative phosphorylation diminishes endothelial cell function and inhibits angiogenesis, the formation of new blood vessels that sustains the tumor growth." And that's pretty amazing that can happen. Just by that one switch of a metabolic reaction, block this neurotransmitter's effects on the tumor growth. Beta blockers blocking the norepinephrine effects, and studies kind of indicated that lowered metastasis, something, whatever. Anyways, I think that's it. So, that's pretty freaking cool.